if we look back in time, at the end of the last lesson, we were talking about something called the 5-number summary for a data set. And I just want to check basically in the chat, tell me what was in the 5-number summary for a data set. So just pop it in the chat very quickly, or if someone's willing to raise their hand. Oh, actually, that would be even better. I saw a hand pop up there for Lasanda. If someone's willing to just tell us what is in the 5-number summary. Might be quicker than writing it out. So I see lots of Q1s. Yeah, let's go to Lasanda. So Lasanda, I'm asking you to unmute. What's in the 5-number summary?
So I think it's the minimum and the maximum value, and then the value for Q1, Q2, and Q3.
You're superstar. Well done. So min, max, Q1, Q2, and Q3. Thank you very much. That was fantastic. Now, what we are going to do today is we are going to practice drawing a graph using the information in a 5-number summary. And the way this is going to work is basically we are going to draw a number line where we put numbers, a scale of numbers that relate to the data set we're dealing with. And then what we're going to do is we're going to find what Q1 is, and we're going to draw a line for Q1. We're going to find where Q3 is. We're going to draw a line for Q3. We're going to, find where Q2 is, and maybe Q2 is here, and we draw a line. And once we've got those 3 vertical lines, we're going to connect them with a box. Okay, where basically the value that we got for Q1 is going to be over that value on the number line. Now, you'll see how this works when we start today, but basically we're going to have that. And then for the maximum value, we'll draw a vertical line and we'll connect it to the box. And for the minimum value, we'll draw a vertical line and connect it to the box. And so this is what a box and whisker plot looks like. And it tells us a story. It tells us the story that the lowest 25% of the data is going to be hanging out in this region. Then the middle 50% of the data is hanging out in the box. And then the top 25% of the data, or the data above quartile 3, is in this area. And it's a very useful skill to be able to draw a box and whisker plot. And what it also allows us to do is we often have more than one box and whisker plot on one number line. And so we can compare different data sets, maybe for boys and girls, or various sets of data that we're comparing. Okay, now we need to practice this, but I just want to quickly check. Give me a thumbs up if you get the basic idea of a box and whisker. Thumbs down if my little explanation was not particularly helpful, or if maybe I just need a bit more detail. Okay, awesome. So what we're going to do is, in the last lesson, we got to that stage over there. Okay, so you can see my data set, and we have worked out the 5-number summary. Now, what I've done over here is I have pre-labeled my number line. But a useful technique to do is, often there's a bit of decision-making that goes into how do I label the numbers on my number line. And a useful thing to do is ask yourself, what is the range of the data set? So if you look at the range of this data set, the biggest number was 526, the smallest was 503. And so, my number line has to, in the least, cover 23 units. Now, in reality, in exams, normally we give you a number line to save time. But what I would probably do in the real world is I would just have my scale going from 500 to, say, 530. So, and then I would just divide it up in a way that makes sense. Okay, it doesn't have to perfectly match this lovely pre-drawn number line. Okay, so I want you guys to attempt to draw a box and whisker plot using the information on the board now. And the information that you need is this information here. We did it at the end of last lesson. This is the minimum value. This is Q1, Q2, Q3, and the maximum. And this was my informal one up here, but I want you guys to draw a box and whisker plot using this number line. And then once you have completed your completed it, I want you to say done in the chat, because I won't be able to see everything you're doing, but I want to give you some time to do this, and then I'll come along and draw my box and whisker plots, and you can compare it to yours.
Mr.
Okay.
S,
Yes,
can you take a question from Kutle?
I can. Yes.
Hi,
So-
sir.
Hey.
I just wanted to know if the scale of the number line has to be constant. So we have to be going up like the same,
Okay.
I don't know.
Good question. So it does have to be constant. It doesn't have to always, you normally choose it so that you try to fill the space that's available to you. But would it have been wrong to go up in fives? No, it wouldn't have been wrong to go up in fives or to go up in ones. It's just a matter of practicality. And what often you see with number lines is they often leave a gap. They don't write every number. So in this
Yes,
case,
sir.
they're writing every second. You could also write every fifth number. But the main idea is when you plot it, it's in line with the right numbers.
Oh no, so because I just wanted to know, because most of the time when we do number lines, they say we can't go from like 0 to 500 and then just start counting it once
Oh, yeah.
from there on.
So what you would do is you start at a much higher number. So because your
yeah.
lowest value is 503, so that's what I was saying at the beginning, I would probably just start at 500 and go to 530, because I know that my biggest, basically the range is about 23. So then I thought, okay, we need about 30 units, give or take. And so I
Yes, sir.
start my number line at 500 and I go to 530. Does that make sense?
Right, sir. Kind of. Because thing
Yeah.
is, you know, when you go like straight from like your number line starts at, let's say 500, then
Yeah.
that would mean you went from like 0 to 500. So the difference is 500. And then
No, so you start, all you do is you draw your number line and your very first value is going to be, say, like 500, right?
also
and
you
then-
don't write 0.
Yeah, so maybe here's an example. I could do 505, 510, 515. Can you see what I'm doing now? It's not exactly
Yes,
the
sir.
same as what 525, 530. So that's a different number line. I mean, I should have put the numbers below the line, but do you see what I'm saying? And now I
And
would,
also like so like I get that part, but like mom, I was just asking because your number line starts at 500, right?
Yeah.
So I'm just wondering because from 0 to 500, that's like the difference is 500. So I would think that maybe the next number would have to be 1000 because you're going up in 500.
you don't have to do that. You don't have to do that. With
Oh,
box and
okay.
whisker,
Thank you, sir.
you just have to keep it in that. Cool.
All right, thank you, sir.
Thanks for the question. That was a good one. Okay, so if we look at the chat, if there are any other questions, what I want to ask, well, let's give a little bit more time. I'll start the process though. So I'm going to draw, where was my Q1? It was 507. So let's say I drew it here, 507. And then Q3 was 515. And Q2 was 510. And so that is what my box is going to look like. Then my biggest value was 526. So that's going to be up here. And my smallest value was 503, which is down here. Okay, so my box and whisker plot should look like that. Now, are there any questions or comments? I'm actually going to ask you about this quarter of the data in a second. But before I do that, are there any questions or comments? Because drawing a box and whisker plot is an important skill we need to know. So while I'm waiting for everyone to finish that, does anybody have a comment about the 25% of data that I've put a blue squiggly line above? What is the long whisker telling me? If I had to interpret the drawing into English, what is that long whisker telling me? All right, so Nawazi is using fancy language. He's saying, is the data positively skewed? Okay, so that's true, Nawazi, it is. What I was thinking of just pointing out is, can you see how spread out this 20%, 25% of data is? Like this top 25% of data is way more spread out. And even this 25% of data over here is also quite spread out. And when the data is more spread out on one side, we say it's positively skewed if it's on the right, or skewed to the right. So basically, yeah, that is correct, Sintimbile. So this particular box and whisker plot would be skewed to the right, because if you look at the distance of between the quartiles, so the distance between the quartiles is bigger, it's more spread out on the right than it is on the left. And so sometimes in questions we'll ask you, is it skewed to the right or skewed to the left? This question is skewed to the right.
Mr.
Okay.
S,
Or positively skewed is another way of saying it. Yeah.
there's a question from Lusanda.
Okay, Lusanda, let's go to you. Hi, Lusanda.
Hello, sir.
Yes, go ahead.
So I wanted to know if is it a must always when you do the box and whisker plotting, must you always draw a number? What's this?
Number line.
Your number line.
All right. Some teachers will let you just draw the label of the number above it. And it's not wrong, but the problem is if you draw two box and whiskers, if you don't have a number line, you don't have a way to compare them. So I prefer that you do have a number line, but it's not wrong. I have seen teachers do this before. So for example, where there's no number line, and then you have that, and they just put the numbers above, like 503, 507, 510, what was the other one, 515. But the problem is, if you don't have a scale, if you're drawing a second one, it's very hard to compare them. So my preference would be a number line, but if you're really running out of time, you could do it without the number line and just write the numbers above it. Does that help?
Yes, sir. So after drawing the box and whisker, do you label if it's positively skewed or negatively skewed?
No. So that's an extra question that I just threw in. If you're just drawing a box and whisker, you're done once you've drawn it.
Okay, thank you.
Okay, let's do another one because we need to practice this. Okay, so I've given you another data set and I've ordered, okay, this is important. I've ordered the data set from smallest to biggest. Now, the reason this is important is that to draw a box and whisker, you need to first do your 5-number summary. And if I do the 5-number summary, my data needs to be organized from smallest to biggest. So I want you guys to find me the min, the max, Q1, Q2, and Q3. And then I want you to draw a box and whisker plot for this data set. So it's over to you guys, you're flying solo. But if there are questions about box and whiskers, I would love to hear them now as you guys are doing this. But I think it's important that you do learn how to do this independently. Yeah, so Nawazi, the most correct way to do it, the correct way to do it is to have a number line underneath. If you have no time left in an exam and you're still trying to draw, it can be acceptable, but you really should have a number line underneath, is my advice. That's all I can essentially say. And it is hard to identify, yes, whether it's skewed or not. Okay, so let's do our 5-number summary. Over to you guys. Now, the one thing I don't know is how many items there are in my data set. So I see N is 12. So that's my little tip for you guys to get you moving along. Okay, are there any questions, guys? While we are busy working hard, I know it takes quite a bit of focus, so I'll let you do it. But if there is a question, raise your hand and we can get to it. Two, 10. So if you could pop your Q1, Q2, and Q3 in the chat, that would be awesome. Just so I know if you're getting the same values that I'm getting. The min and max is pretty straightforward, but I want to check that you are getting the same Q1, Q2, and Q3 as me, because that will affect our box and whisker. Let me start with this one. Let's see. Okay, so what are we getting for Q1, Q2, Q3? So if I'm between, position 3.25 is between here and here. So we should get a value of 4. Q2 is between 10 and 11, so we should get 10.5. And, oh yes, Sitimbile, Q1 is 4. Novosetu, Q1 is 4. I agree with you. And I get 10.5 for Q2. And then Q3, it's between 14 and 16. So that is going to be a value of 15. Now, all I'm doing is I'm adding them together and dividing by 2. Yeah. So something that I do want to point out is that the quartiles, you average, but if you fall between, if your position is between 2 values, you average them out. But when you're dealing with something like percentiles, you would round to the nearest number. And so that's just something there is a difference between those two. But once we've got these numbers, I want you guys to go ahead and draw your box and whisker. Now you'll see I put my scale in here. My scale's not perfect, but it's still correct. Have I covered all the numbers that are involved? I go from 0 to 20. Maybe I could have chosen a different scale. It doesn't really matter though, as long as I'm consistent in this scenario. And so when you're done with the box and whisker plot, won't you just let me know by saying done in the chat? That would be awesome. So 4, Q3 is 15, Q2 is 10.5. And then the max was up to 18 and the min was down to 3. Okay. So if I look at this data set, it does look, it looks good to me. And you'll notice that some students are commenting about skewness. Now, at this stage, we haven't been asked anything about skewness, but I think you can kind of see which part of the data is most spread out, right? If you think about this is the median, this is Q2. You can see the top half of the data over here is more closely together than the lower 50% is more spread out. And so you would say that this data set is skewed to the left or negatively skewed because it's essentially more spread out to the left. Okay, but that wasn't specifically part of the question. I'm just responding to the chat below. But yeah,
Mr.
you do get
S?
asked about it. Yeah.
Sorry, Mr. S. Are you able to take a question from Mukelani?
Yes, Mukalani, let's go to your question. What's your question?
Hello, sir.
Hey. How can I help you?
I just have okay, so I saw that you only put 4 ones when it comes 3 times.
I only
Right?
put 4 once when it comes 3 times.
Like by the number line,
Oh, yes. Okay. The thing is, when I calculated Q1, I was looking at position 3.25. And so I counted position 1, let's go like, basically I was doing this. Position 1, position 2, position 3, position 4. I knew the position was between the 2 4s. And so if I add 2 4s together and divide them by 2, I still get 4. Does that help?
No, so my question was like by the number line, the one by the box was getting.
Yes.
You only wrote 4 ones. That's what I'm saying.
Okay.
So if you get a number.
Yeah, I get what you're saying. So remember, this is a number line. This number line is going to show every number once. And this box and whisker plot is a summary of 5 values. It's the min, Q1, Q2, Q3, and the max. So because the 4 only comes up once in those 5 values, I'm only going to, does that make sense? Like the 4 is not going to be repeated. The data set repeats 4, but the box and whisker plot won't repeat the 4.
Yes, sir, that makes sense. Thank you so much, sir.
Pleasure, man. Pleasure. Okay, let us, before our break time, are there any questions or comments? Otherwise, I want to squeeze in one more of these before our break.
Mr. S, there's a question from Asanda.
Okay, Asanda.
Hello, sir.
Hey.
So I wanted to ask, I got mine wrong because I calculated the positions correctly, but I don't know when I should like add the 2 values and then I don't know when to like the difference.
Okay. If the position is a fraction and you're dealing with quartiles, so this is important. If you're dealing with quartiles and your position is a fraction, it will fall between the two values. And all we do when it falls between 2 values is we take the average of the 2 values closest to it. So the average of 4 and 4 is 4. The average of 10 and 11 is 10.5. So basically I'm adding the 2 together and dividing by 2.
So how do I know? Because I remember with the previous lesson, you said we should move to the next digit. Like, how do I know?
So in the previous lesson, we weren't talking about quartiles. We were talking about something called percentiles.
Mm-hmm.
So that's important. If you were dealing with percentiles, you do go to the nearest value.
Okay.
So that's an important difference. And thank you for bringing it up. That's an important difference. Yeah. And
Thank you, sir.
just a difference in terms of the method. Yeah. Okay. Awesome. All right. I tell you what, let us have our little break and then we will come back after the break to continue with this. So what I want is everybody standing up, turn your cameras on, and I want to see you stretching like you are an aerobics instructor. Is that too much to ask? Maybe it is, but give it a try. So just stand up and just stretch your body out, roll your shoulders. Show us some of your lovely faces. I promise you it's not going to be recorded, but we love seeing the humans out there with us. Makes us feel like we're going on a journey. There we go. Look at those people. Lisa, Owazi, Lebo, Lusanda. Oh, now I feel like a teacher. Awesome.
Shout out, guys. Duelo, Tando, William.
Look at that. Oh.
Nancy, Chalanati. Awesome, guys.
Yes. Oh, And doesn't that feel good? Doesn't that feel good? Where are the young gentlemen in the group? I only see young ladies. Where are guys? You got to be stretching it out here. Okay.
The ladies take the cup this time.
All right. Time for a brain break. So this looks a bit like Angry Birds. So guys, I want to know what a monkey minus a, I don't even know what that is, some sort of bird times a bee is. Let's see if you can work that out for me. Okay.
Cameron says the chicken is 4.
Chicken is 4, I agree. There's no other way that we're going to get something times something plus 1 is 17. So I agree with Cameron on that.
Those bees are quite fat, hey?
Yeah, eat lots of pollinating as the bees do. Okay, so what is the bee going to be? I agree, it's going to be 3.
3.
Now there are 3 monkeys here, so be careful. There are 3 monkeys. So how much is each monkey going to be? And then that should unlock to get the final answer.
Now Cameron says the fat bee.
The fat bee. Well-rounded. There we go.
Well-rounded. I like that.
Okay, so I see William has said each monkey must be 2 because the total of monkeys must be 6. So what is my final answer going to be? So Nada's got it. Each monkey is 2. So what is the final answer going to be? Now be careful because BODMAS is your friend here. Maybe it's not your friend. I don't know. I don't know how well you know BODMAS. But 2 minus 4 times 3, in order of precedence, this is going to get done first. So to me, oh, there we go. Quenzi, Zinkle, I think you've got this. It's going to be minus 10. Oh, it's going to be, get that? Huh. All right. It's going to be minus 10. There
Nice
we go.
one, guys.
All right. So respect Olwetu, Anika. I see all of you guys are looking good there. All right. You don't like the answer. I know, it's hard to be negative, Cameron, but sometimes in maths it happens. So let's roll with it. Okay. Cool. So let us do another one. And actually, you know what? Let's skip this one up. I think you understood the basics of box and whisker. Let's do some multiple choice questions here. So in this particular multiple choice question, what does the point C on the box and whisker plot represent? So Onele, can the whisker diagram have equal sides? It can, Onele. If that's the case, we say that the distribution is symmetrical. Okay, so if the box and whisker, if the median basically divides 2 halves that look the same, it's symmetrical. Okay, so the answer for this one is going to be the median. So Q2, or the median. Yeah, that wasn't so bad. Awesome. What happens, I'm just going to answer this while we're talking about distributions because it's coming up naturally. What happens if basically the median basically the distribution looks the same on both sides? And that type of distribution is called a symmetrical distribution. Now that is not skewed to the right or skewed to the left, it's symmetrical. In this particular distribution, but for bonus points, is this data skewed to the right or is it skewed to the left? Okay, just as an interest, out of interest, based on what we've been talking about today, do you think this data set is skewed to the right or skewed to the left? And the tip I'm going to give you is I often look to see which half of the data is more spread out. The part that's more spread out is generally the side which it's skewed to. Yeah. So you can see like between Q2 and Q3, that's actually the most spread out, 25% of data. And then this part on the whole is way more spread out or skewed to the right. And so this data set would be skewed to the right, or we could say it is positively skewed. Because just think about how the number line goes. It's positive to the right, it's negative to the left. Okay, we're kind of jumping ahead, but it seems to be a natural progression. All right, let's go to the next question. What is the interquartile range for the box and whisker plot shown above here? What is the interquartile range for the box and whisker plot shown above here? This is interquartile range. Q1 is here and Q3 is here. So it should be 9 minus 4, which is 5. Yeah. Awesome. That's what I'm seeing in the chat. So you guys are winning at life there. Okay. Next question. And just shout if I'm going a little bit quickly. I'm getting the impression that this is fine pace, but you can let me know in the chat if it isn't. What is the range and interquartile range for this, this particular box and whisker plot? So it's asking for two things: the range, which is, one way of measuring how spread out the data is, and the interquartile range, which is another part of it. So remember, range is max minus min, and interquartile range is Q3 minus Q1. So the biggest value here, or the smallest, is 4, and the biggest is 18, which makes me think my range is 14. And my IQR is, that looks like 15.5. And this looks like 5.5. So that should be 15.5 minus 5.5, which is 10. Is there anything that is 14 and 10? It's B. Yeah.
Well done, guys.
Lots of B's. Oh, sorry. Getting too excited, guys. Just calm down, Pete. Calm down. Okay. So, next question. So which option do we think this one is? So they're asking quite a lot. They're asking for the median, the range, and the interquartile range. So for me, Okay, so those are my, remember that the median is the same as the Q2. And the option that I see that matches everything is 14. So definitely not this, definitely not this. Wait, 6.5 for the median. Interquartile range is 10. Q2. Wait, maybe I got it wrong there. D range is, why is my, so range 14 minus 0. I should get 14 for my range, 6.5 for the median, and then interquartile range is 10. So it's D. Yeah. Correct answer is D. Oh, you guys are getting this so quickly. I'm like, okay, let's have a little bonus question. Since we've been talking about skewness, tell me, is this graph skewed to the left, skewed to the right, or is it symmetrical? What do you guys think? If we look at the distribution, the way the question is phrased is, if you look at the distribution of the data, like how squeezed up or how spread out it is, how would you describe that? This one's a little bit more debatable, I guess. So it's almost, it's not quite symmetrical. I can see why some of you are, if you look at the whiskers look symmetrical, but look at the box, and you look at which is the box equal? Is the median dividing up the box equally? So here's my median, and what you notice is the data between Q2 and Q3 is quite a bit more spread out than the data between Q1 and, well, not crazy amount, but a reasonable amount. And so I would say it's positively skewed or slightly skewed to the right. Yeah. Okay. Well done. Okay, let's do this one. Write down the 5-number summary of set A and set B. Now, this is what I was telling you about earlier, guys. What they like to do sometimes is they like to put 2 data sets on the same number line so you can compare them. And so I want you to write down for me, what is the 5-number summary of set A and what is the 5-number summary of set B? Imichle, let's come to you. What's your question?
Hi.
Hey, how's it going?
I wanted to ask. I'm okay. I wanted to ask. Since for the diagram before you said that it was positively skewed to the right, if it was skewed to the left, did you say it was negatively skewed?
Yes. Yeah. The way I think of it is the number line. So, like, you know, on the number line to the right is positive, to the left is negative. That's the way I remember it.
Yes, sir. Okay, thank you, sir.
Pleasure. Kuchle, what's your question? While students are working, let us this out.
So I was just wondering how you determine whether the thing is negatively skewed or positively skewed, because I thought that it would have to be, if the mean is less than the median, then it's negatively skewed, and then if the mean is more than the median, it's positively skewed.
Okay, so this is not as common anymore, but if the mean, I wouldn't stress about this. There's sometimes, yeah. So, let's say positive skew. So I always look at the mean, and if the mean is great, I always think about the mean as the thing that you're comparing to the median. And that is true, Kuchle. So if you're interested about knowing, but most of the time in these questions, in exams, they give you a visual representation and you have to use that to judge. But you're right, there is another criteria, but that would be that if the mean is greater than the median, it's positively skewed. The mean is less than the median, it's negatively skewed. But I'm not going to say too much more than that at this stage.
All right, thank you, sir.
Cool. So for set A, I see 25 as my lowest number. I see 30 as my Q1. 50 as my Q2, 70 as my Q3, and 140 as my thing there. And then for set B, we have 5, and then we have 15, 20. Oh, this is interesting. 30 and 30. That's set B. So if we look at the set A and set B, would anybody like to come online and tell me some of the obvious differences? Because sometimes you're given two data sets and you have to talk about the difference between them using a box and whisker plot. Would anybody like to give some commentary? Otherwise, I'll do it, but I'd love to give someone a chance in the class to offer some commentary about how are these two data sets different?
So
Yeah.
set A has a much larger range compared to set B.
Yeah. So if you look at the spread of the data, set A is got a much larger range, and especially the top 25% of data. So between Q3 and this bit, this is really far spread out, whereas with set B, it's actually like the maximum value is the same as Q3. And so that top 25% is basically just going to be the same item, which is a bit weird. It's obviously a very small data set. So the main commentary would be that this is far more spread out. And that would be one of the ways of offering it. Otherwise, the thing that stands out is the whisker that goes way to the right. Awesome. So something else that, okay, we're not going to have time to go into that today, but that was actually, sometimes some people would ask a question about like things like outliers and stuff, but for now, I'll leave that. Okay, let us end with this question. So this is a box and whisker plot of boys and girls. I think this is probably around about grade 7 or something like that. So this is not adults. I want to know for data set A, the boys, is it skewed to the left or skewed to the right? And for the data set B, is it skewed, the girls, is it skewed to the left or skewed to the right? And we'll finish with that for today. Yeah, Amukalani, there's a question.
Yes, sir. Can you just go back to the one before? I just want to see something quickly.
Okay, let me see if I can zoom in a little bit, then you can you see both questions now?
Yes, thank you so much, sir.
Pleasure. Make this bigger. So we're just asking ourselves for each of these data sets. So the thing that draws my attention is for the boys, the bottom 50% of boys in the distribution, right? So it's a much bigger spread for the lower 50% than the upper 50%. And so I would say that the boys are skewed to the left or negatively skewed. Whereas with girls, the upper 50%, so imagine a collection of girls and that you rank them from heaviest, from lightest to heaviest, the top 50% is far more spread out than the bottom 50%. And so we would say then that they are skewed to the right or positively skewed. Yeah. So if you look at these data sets, when you're looking at skewness, you look at either side of Q2, right? The median. But often the distance from the boxes on each side or the whiskers can both be helpful in figuring out which side is larger. And in my brain, what I remember is just the more spread out side is the one that gets the attention. That's the one that you're going to comment on. All right, Lebo, if I could ask you to put the link to the quiz in the chat. I will take 1 or 2 more questions, but I just want to allow students we're pretty much done for today. It's a good place to stop. In the next lesson, we are going to be shifting to what's called grouped data, guys. So up until now, we've always been doing lists of data, and we're going to start to work with data in tables in the next series of lessons, and how we work with frequency tables, cumulative frequency, these types of things. I also want to encourage you that if you want even more questions, there is a second recording of another class that I do that sometimes has additional questions. And so if you feel like you want more on something, you can always watch that video at a later date. Amichle, yeah.
Sir,
Yeah.
I wanted to ask, so when you're determining whether it's skewed to the left or the right, do you look at the box or do you have to look at the whiskers?
I lost you. I lost you for a second. Okay.
Oh,
Maybe my internet's good. Yeah.
I was saying
Let's have a
when you're
Yeah.
looking at whether it's skewed to the left or the right, do you
Yeah.
have to look at the box or do you have to look at the whisker?
You look at both, to be honest. You have to look at both, but generally there will be a trend that you can pick up. Does that make sense?
Yes, sir.
Yeah, but there is generally the questions will be pretty clear. There won't be too much ambiguity, but you look at both. You look at both, to be honest. But generally they'll both, yeah, is the honest truth. Yeah.
Okay, thank you.